morning. Title of my presentation is Diffeasible Logic Programming and its Application. The outline of my presentation is Introduction of Diffeasible Logic Programming, its framework, different extension of diffeasible logic programming, different application of diffeasible logic programming, followed by references. Research in the area of logic programming, non-monotonic reasoning, and argumentation provide us some important results, and these important results provide us some powerful tool for knowledge representation and reasoning. So now we'll see what is diffeasible logic programming. Diffeasible logic programming is a formalism that combines the results of logic programming and diffeasible argumentation. So now what is argumentation? Argumentation is a human-like mechanism that contributes to formulate common sense reasoning. Argumentation basically associated with different arguments which stands for or stands against certain conclusion. For example, X and Y went to buy a car, and X put forward his argument that he do not want to buy this car because the car is second hand, and Y put forward his argument that though this car is second hand, it is well maintained, so they want to buy this car. So the conclusion of that argumentation will depend the person who provided the strongest argument. Now we move to logic programming. Logic programming is a set of rules defining a relationship between two objects. The main characteristics of logic programming are number one, relationship, and number two, inference. So let us consider a situation where we have two statements. A is the father of B and B is the father of C. So relationship between the object A and B is a father-son, and relationship between B and C is also father and son. So from these two statements we can infer that the relationship between A and C is grandfather and grandson. Logic programming and argumentation provide the foundation for diffeasible logic programming. Now the question is where you can apply diffeasible logic programming. We can design intelligent agent using diffeasible logic programming and multi-agent system. So now, what is intelligent agent? Intelligent agent is an autonomous entity that observes its environment and acts upon it in order to achieve certain goals. And multi-agent system is a set of intelligent agents which coordinate with each other in order to achieve certain common goal. So now, we'll see what is diffeasibility. Diffeasible logic programming adds the possibility of representing information, number one, in the form of weak rule in a declarative manner. Number two, diffeasible argumentation inference mechanism for warranting the conclusion that entailed. So now what is weak rule? Weak rule is a key element for introducing diffeasibility. It represents the weak relationship between the two pieces of information. Let us consider a statement: sun rises from east. No one can contradict this statement. This statement will be always true. But we'll consider one more statement. Like, we celebrate Christmas during winter. Yes, the statement is true for me. If a person who is from US, for his also, the statement will be true. But for a person in Australia, the statement is not true, because they celebrate their Christmas during summer. So this kind of statements, when you consider all the information, it come up with some different results. So we call this kind of statement as a weak statement. The connection could be defeated after all the informations are considered. So now we'll see how argumentation works with a well-known examples. We have three statements: bird usually flies, penguin usually do not fly, penguins are birds. So we call first statement as a weak statement because sometimes it is true, sometimes it is not true. For the penguin, kiwi, for those kind of birds, they cannot fly. And we call other two statements are strict rules because this cannot be contradicted. Penguin cannot fly and penguins are bird. These are the obvious informations. So now we have a statement with us, Tweety is a penguin. So now we try to construct arguments from those statements. So argument A, which is based on the rule 1 and 3, Tweety is a penguin, penguins are bird, and bird usually fly. So we can conclude that Tweety flies. Argument B, which is based on the rule 2, we can obtain Tweety is a penguin, penguin usually do not fly, so Tweety do not fly. So now we have two different contradicting conclusion from those three statements. So now the question is, which statement or which conclusion we should consider? We'll consider the argument B over argument A because this is more direct. We have straight information like Tweety is a penguin, penguin do not fly. So our conclusion is Tweety cannot fly. So now we'll see what is diffeasible logic programming. Diffeasible logic programming, P is a set of two tuples, pi and a delta. And pi is a set of facts and strict rules. Fact is a ground lettering. For example, we have a statement, Tweety is a penguin, so we can represent in this form Tweety penguin. So now strict rule is used to represent, we use a right arrow to represent a strict rule. These are the obvious information, these are the statements which cannot be contradicted. Like penguins are bird, this kind of statements cannot be contradicted. Now delta, which represents the diffeasible rules, we use a special symbol. This is used to represent a diffeasible rule or weak rule. For example, we have a statement that bird usually flies. So this is a diffeasible or weak statement which can be defeated. So now if we represent that information in the form of diffeasible rule, then we can represent in this way. We'll have two strict rules, the bird, penguins are bird, penguin do not fly, and one diffeasible statement that bird usually flies. And the fact available with us that Tweety is a penguin. Now we'll see how diffeasible derivations are different from standard derivations, because here we considered diffeasible or weak rule in the derivation process. So now we'll see. So this is a small diffeasible program where we have three strict rules, three diffeasible rules, and three facts available with us. What those strict rules states: the chicken is a bird, penguin is a bird, penguin do not fly. And what diffeasible rule states: birds usually flies, chicken usually do not fly. Chicken, if it is scared, then it will fly. Then three fact available with us that Tina is a chicken, Opus is a penguin, and Tina is scared. From this diffeasible program, the following these derivations can be obtained. Number one, Tina is a chicken, Tina is bird, Tina flies. Number two, Tina is a chicken, Tina flies, Tina do not fly. Sorry. Number three, Tina is a chicken, Tina is scared, and Tina flies. And number four derivations, Opus is a penguin, Opus is bird, Opus flies. And number five derivation is Opus is a penguin, Opus do not fly. These are the diffeasible derivations which can, possible diffeasible derivations which can be obtained from this diffeasible program. So now we'll see how diffeasible argumentation can be constructed. We have a small diffeasible program with us. It consists of 6 diffeasible rules. What these rules states that if person is not responsible, then he should be suspended. If person is unruly, then he should be suspended. Person is responsible, then he should not be suspended. If person is a poor performer, then he is not responsible person. If person is a good performer, then he is responsible person. If person is a good performer, if he is sick, then he is a responsible person because he will be always in the fear of his job. So we have two facts available with us. That poor performer, John is a poor performer and John is sick. From these two facts and using rule number 6, we can obtain that John is a responsible person. And from this information and using rule number 3, we can obtain that John should not be suspended. So like this we construct the argument for John should not be suspended. So now we'll see how dielectric tree is used to derive a conclusion in argumentation, diffeasible argumentation process. So we construct a diffeasible node, the node in a dielectric tree for John should not be suspended. So using those facts we can obtain one more node using rule 4 and rule 1. We can obtain that John should be suspended. But here both the arguments are contradicting each other. So now we can obtain one more argument from this available fact that John is a responsible person, and it will attack the sub-argument of this argument, John should be suspended. So now this tree, from this dielectric tree you can derive that this node is got defeated. How? Because the conclusion or argument where it is supporting is based on the lesser fact as compared to other nodes. So this node are attacking, these two nodes are attacking this node. This node is got defeated, and as that node is got defeated, so we can conclude that John is a responsible person and John should not be suspended. So now using dielectric tree, the diffeasible argumentation, conclusion for a diffeasible argumentation can be obtained. So now you can see that this is the framework for diffeasible logic programming. We submit a query, we have the diffeasible rule with us, which consists of diffeasible program with us, which consists of diffeasible rules, street rules, and fact. We submitted query and diffeasible to the interpreter. Interpreter compute the dielectric tree by backward chaining and give us the conclusion. And what are the possible answers? If that argument or the query is warranted, then answer will be yes. If that argument, contradiction of that argument is warranted, then it will be no. If both conditions do not exist, then answer will be undecided. So these are the different types of diffeasible logic programming. The diffeasible logic programming is used to address vague informations. And time component is used in the diffeasible logic programming to address the time issues. So temporal diffeasible logic. So now probabilistic and temporal diffeasible logic, where both probability and time components are addressed. So now we'll see different applications of diffeasible logic programming. In my MS dissertation, I have used diffeasible logic programming for firewall verification and reconfiguration. Before explaining that, I want to explain what is firewall. Firewall is the application that stands between domain, our own domain, and public network. So firewall work according to the configuration of its rule set. So if some packet violates any of its rule, then it will block that packet and it allow or illegitimate activity. So, in the configured rule set, there might be different type of anomalies might occur. So these are different types of anomalies: shadowing anomaly, correlated anomaly, generalization anomaly, and redundant anomalies. In our application, we try to find out these anomalies, try to remove these anomalies from the rule set and reconfigure it, and try to provide the user a anomaly-free firewall. So this is the defeasible logic programming which we use to find out the anomaly and for the reconfiguration of the firewall. So this is a strict rule. Strict rule states that if the rule has a valid protocol address, source IP address, source destination address, and source port, destination port, definitely it will be a valid rule. So no one can contradict this statement. And we have few defeasible rules. Initially we will say that any valid rule is a conflict-free rule. If any anomaly occurred with that rule, then we will consider that rule as a not conflict-free rule. So like that. And these are the rules which is used to obtain different anomalies. That here we will show one defeasible statement to derive a redundant anomaly. So now we will see the architecture of my tool. We have a rule base with us. The rule set, from the rule set, rule relation analysis engine try to determine the relationship between the different fields of the rule and generate the fact, and we store the fact in the knowledge base in the form of facts. And defeasible program for anomaly detection use those facts and as a input to the program, and the whole program is loaded in an interpreter, and the rule analysis and reconfiguration engine will query and try to find out the anomaly among those rule sets. And whatever the answer he got, from this information he tried to generate some additional fact which will be used by same engine to do for the reconfiguration of the firewall rule set. So we will generate those facts and resubmit it to knowledge base in the form of fact. Then from those facts, newly generated fact and available facts are used by defeasible logic programming for anomaly removal. And this removal is loaded in the interpreter, and again rule analysis and reconfiguration engine try to find out the different configuration mechanism to reconfigure the firewall to provide us an anomaly-free rule set. So this is the architecture for the DLP based verification and reconfiguration of firewall rule set. So now we'll see different applications where defeasible logic programming is widely used. Kappa robot, used in a Kappa robot for decision making in that environment, in its environment. Then modeling the news trust, decide whether the information is trusted or not. Information source from where the news is coming is trusted or not. Then in stock market, you need to keep monitoring different informations of stack informations. Okay, using defeasible logic programming, people try to people designed stock market agent. We keep monitoring this different informations of stock market and development of recommendation server and argument based decision support in the private law forms. So these are the references, and thank you very much.